floor level. And it would also then result in much higher values here and here. So, how to continue now? So this was the first measurement for the first command, in this case a request A, for a certain field strength. But, as mentioned before, you have to make many measurements with basically all commands in this test command sequence. So, you see here in this procedure, you have three options. The X option always means you can abort the procedure. C is continue with the next command, and R is repeat the previous command. In this case, the measurement went fine, everything was okay, so you do not have to repeat it, you can continue. But for example, sometimes the oscilloscope is not able to find the correct trigger point, and then you will not see such an image like this one here on oscilloscope, but something very different. In this case, you have to repeat the command in order to ensure that the measurement is correctly made. But now we want to continue, so I press the C button. So the next command would be anti-collision. You see here, the thing is, you have to ensure that the command can be reached. So typically you have to start again with request, and then you continue with the next one, anti-collision. So the trigger is only fired at the last command. So that's why it's called target command. So if you see that if you look at that on the oscilloscope, you will see an image which looks kind of similar to the previous one. So of course the reader signal is longer just because the anti-collision command, the 9320, is longer than the request. It's 2 bytes instead of 1. And you see again that the distance between between the end of the reader transmission and the beginning of the card transmission is very short. So, but this image is correct. So you can now repeat the steps which you did previously. So you have to again use the EMD checker software. At first you have to check the TEP-SCC value, which in this case is 10.75 microseconds. You enter this value here, and you make a capture trace. Okay, as you see, the signal is correctly grabbed. And the default setting, after one capture, the default setting of the area width between start and stop cursors is always set to maximum. If you move it again, the stop cursor, you see it narrows down based on the TEP-SCC. And again you do the same as before. You move it as close as possible to the card's response. So have a look at the USB and LSB max values, how they change. You see very few changes here. Of course here you have a very high value because you're in the middle of at the end of the reader signal. So here you have low values, and if you move in this area you have high values again because you capture the load modulation amplitude of the card. So you move it here right to the beginning. So, and again you can read out your EMD values. Please note that you have to write down these values by yourself. They are not stored in the software. Okay, let's continue with the next step. So, command went fine, so we go to the next one, which would be a select command, a 9370 in this case. So, just connect. Looks like this on the oscilloscope, of course, again a bit different because the select command is much longer than the previous ones. Again a short distance here. So, I won't repeat this procedure because it's basically the same. You see in this case that the TEP-SCC value has changed, it's a bit longer here, which means that the distance between the end of the reader command and the beginning of the card response is longer. So let's continue with the next one. After select we have RATS, which looks like this. and you see the distance has enlarged between reader command and card response. In this case it's 86.1.